So hey guys, in this video we will be discussing about the breadth first search algorithm for a graph. Okay, in the previous one we had discussed about DFS. Okay, and in this one we are discussing about BFS. So both these algorithms are very important, and I would say dedicate a good amount of time in order to learn these two algorithms properly. Okay, so let's start with our BFS algorithm. So let me make a sample graph that we can discuss our BFS approach on. Okay, so let's consider that this is the graph that we have. This is the graph that we have. So how many number of nodes are present in this graph? So what is the total node count of this graph? So we have 0, 1, 2, 3, 4, 5, 6 and all the way up till 7. Okay, so total of 8 nodes are present in this graph. Okay, total of 8 nodes. And how many edges are present in this graph? Okay, so how many edges are there? So you have 1, 2, 3, 4, 5, 6 and 7. Okay, so total of 7 edges. Okay, let's count it again. 1, 2, 3, 4, 5, 6 and 7. Okay, so we have 7 edges and 8 nodes in this particular graph. And what is the type of the edge that we have here between the nodes? So as you all know that there are two types of edges in a graph. That is like one is a directed edge. Okay, so one would be a directed edge and other would be an undirected edge. The directed edge will always contain an arrow which will indicate that from which node to which node is a movement possible. Okay, so if you had a directed edge between 0 and 1, say something like this, so it would say that you can move from 0 to 1, but then not from 1 to 0 back. Okay, so this is what it means by directed edge. However, in undirected edge, we have no arrows associated with it. So it's a convention that we follow that we do not put the arrow itself. So this indicates an undirected edge, which basically means that here you can move from 0 to 1 and also from 1 to 0. Okay, so in this graph, the type of edge that we have, okay, so the type of the edge that we have here is undirected edges. And like before I actually move on to the BFS algorithm, I would like to talk about a data structure that is known as queue. Okay, so this queue is something that we'll be using in BFS, and that's the reason why I'm discussing this queue data structure over here. Okay, so this queue is a linear data structure. The very first point is this queue is a linear data structure and it works in a first in first out manner. Okay, so FIFO manner as we all say. So first in first out manner. Okay, so this queue basically works in a first in first out manner, and it has something known as the front part of the queue. Okay, so this is the front part of the queue, and it has something called as the rear part of the queue. Okay, so these are a couple of terminologies that you need to remember. So this is a linear data structure, that is the ordering of the elements in the queue can only be one after the another. It cannot be having a hierarchical structure like a graph or something. So this is a linear data structure, the very first point. Then it works in a first in first out manner. That is like whatever element you push into the queue first will be the element that will be processed and taken out of the queue first. Say for example, you have certain nodes such as A, B, C and D. Okay, so if you decide that you want to push the element A into the queue, just note that A will go from the rear end of the queue and sit inside the queue something like this. Okay, so the queue initially was empty, and now when you push the element A into the queue, it goes and sits something like this. Now next you decide to push the element number C into the queue, so it will go and sit after A. Okay, it will go and sit after A. Okay, so this is the point that you need to remember. The order in which, okay, so the order in which you push the element into the queue is the order in which they will get executed. Okay, so if you put the element A, C, and then we decide to put the element D after that, so D will go from the rear end of the queue and sit after C. And then you have which element is left? We have B left. So B also, if it push, it goes and sit after D. Okay, so this is the order in which the elements would be present in the queue. And whenever we start processing the elements in the queue, right, so it will basically take the element from the front part of the queue. Okay, so front में हमारा क्या है? हमारा है A वाला element. So it will take the element A out of the queue and maybe it will process it. So this A will be taken out of the queue and the new state will look something like this. So you'll have C, D and B. Okay, so now if you try to access the front element will basically point you to the C element. ठीक है, क्योंकि हमने A already निकाल दिया है process करके, and the next element that is that needs to be processed is the element C. Okay, so when you process C and take it out of the queue will look something like this. So यहाँ पे आपका D और B होगा, and when you access the front element, it will give you the element number D. ठीक है, so यहाँ पे you see that the order in which we have pushed the element is the order in which they are getting processed. Okay, so this is the simple point that you need to remember regarding a queue data structure. Okay, okay, let me erase this first. Cool. So there are a couple of operations that you need to remember when it comes to queue. The very first one is empty check. Okay, so this is, I am explaining you with reference to C++ STL container classes. Okay, so C++ STL container के respect में I am just explaining you these functions. In Java, it might be a little different. You have something known as poll, peek, etc., etc. But then here I'll be explaining in terms of C++, and there, so you can just research about this similar operation in collection framework present in Java or any other language of your choice. Okay, so the very first operation is empty check. So empty check क्या करता है? At any given point of time. Okay, at any given point of time, when you query about the queue, मतलब queue के अंदर कितने element हैं, is the queue खाली, मतलब is the queue empty or not? Okay, so this function basically returns true or false, indicating whether the queue is empty or not. Okay, so this function returns true or false. Okay, so it will return true or false depending upon whether the elements are present in the queue or not. मतलब queue के अंदर कोई element है कि नहीं है, it simply states that. ठीक है, so यहाँ पे A, C, D, B है queue के अंदर, so there are 4 elements that are present in the queue, and that's the reason why the empty check, when you call an empty check, it will return us false. Suppose that we removed all the elements from the queue using the pop operation, so I'll just come to that next. Okay, so suppose we removed all the elements from the queue and the queue looks something like this. Okay, so it doesn't have any elements over here. Now if you do an empty check, okay, so now if you do an empty check, it will return us true. Okay, so this empty check is the first function that you need to remember. Second function that is important is the push function. Okay, push will take an element as a parameter. Okay, so this element is something that you want to push into the queue. Okay, so we were pushing what all elements? We were pushing A, C, D, and B in the order, right? So when you want to push an element, like say for example, you want to push the element A. So element A, so we'll be making a call something like push A. So it will take the responsibility of taking the element A and pushing in the rear end of the queue. Okay, so next we have a C. So it will invoke this particular function something like this. It will take the element C and put it at the rear end of the queue. Okay, so this is the push element function. Okay, and let me clear this up a little bit. So next we have the pop operation. Okay, so we have the pop operation. So pop operation doesn't need any parameter because it knows that whenever it wants to remove an element from the queue, it is always the first element that needs to be removed. So the pop operation, this pop operation, it will remove the front element of the queue. So this is something that you need to remember. It will always remove the front element of the queue. Okay, then we have an operation known as front. So this front function, what it does, it gives you what is the element present in the front of the queue. Okay, so it gives you the element, and this pop function removes the front element. Okay, so just understand the difference. The front function, it will just give you the element. Say for example, you have a queue something like this. Okay, this was becoming dirty, so let me erase it. Okay, so imagine we have a queue something like this, A, B, and C. Okay, so this is the state of the queue right now. Okay, so this is our queue. And its name is may for example, this is the name of the queue. And when we do a queue dot front operation, okay, so queue dot front, when we do, it will give us the element A in return. Okay, so A will be returned for this queue dot front operation. Now when we do a queue dot pop operation, here it will remove the first element from the queue. Okay, it will remove the first element of the queue. It is a void function. Void function matlab it will just remove it. It won't return you the element. It will simply remove the element from the queue. Okay, so it will simply remove the element from the queue. So this you need to remember between pop and front. All right. So next I would like to talk about something known as visited array. So visited array is something that we maintain information whenever we visit a particular node. This visited array would be of the size of the number of nodes. Okay, so if you just take an example of this one, right? So how many nodes were present here? So the total node count is how much? It is 8, right? So the visited array will always contain the size equal to the number of nodes. Okay, so here we have 0, 1, 2, 3, 4, 5, 6, 7. Okay, so I think 7 तक ही होगा यहाँ पे. ठीक है, so this is total of 8 nodes. Okay, so the very first thing that you need to understand is this visited array, it will store the Boolean values. It will store the Boolean values indicating whether that particular node was visited or not. तो यहाँ पे हमारे कितने नोड थे? यहाँ पे हमारे 8 number of nodes are present. So visited array का भी size 8 होगा यहाँ पे. One box corresponding to each of the vertices present in this graph. तो 0 के लिए, so this particular node, for this 0, we have this particular box over here. For node number 6, we have the box, this particular box over here. So this box, okay, so a query to this particular visited array simply indicates whether that particular node was visited or not. Okay, so when you would be traversing the graph via the BFS function, it will simply keep track of the nodes that you have already visited. Okay, so if you just imagine karo ki you started your journey from 0, you have already visited this particular node, then you move on to the next other node. So imagine that you move to 2, and then you move to 1, then you move to something like 3. So how do you track this particular information, like which all nodes have you already visited? So that is via the visited array. So initially सारे के जो values होंगे, so all these values would be false. ठीक है? So initially when we have like not even started our traversal, right? So all these values would be false, indicating that none of these nodes are visited. When we visit a particular node, say for example, if we had imagine that we have already visited these 4 nodes, so what will be the state? Okay, in that case, so in that case our visited array will look something like this. So we had 0, 1, 3 and 2. Okay, so 0, 1, 3 and 2. Okay, so these would be containing the value true. Okay, these would be containing the value true, and whenever you query this particular visited array, so visited of 2, like if you want to just find out whether 2 was visited or not, मतलब इसको हमने देखा है कि नहीं देखा, how do we determine programmatically? It is via the visited array. So we just query visited of 2. Okay, so in the program maybe we'll have something like visited of 2. Like just tell me whether 2 was visited or not. We simply query this array, it will return us true. So our program will say, okay, yes. Our program will say, okay, yes, this 2 has already been visited. You don't have to worry about it. Okay, so that was about visited array. All right, so this, you don't have to maintain it as an array itself. You can maintain an unordered set also or something like that. It's totally up to your choice, like what you want to use. So we just need a means to store the details of the visited node. मतलब जो node हमने visit कर लिए हैं, we just want to store it somewhere so that we can query in optimal time. Okay, so just tell me whether this particular node is visited or not. Just tell me fast. Okay, so that kind of operation is possible via this visited array. So now let's come to like how does the processing operation happens for BFS. The very first point that you need to remember, okay, so very first point you need to remember when it comes to BFS is it processes the node in a layer by layer manner. Okay, so this is the sentence that you need to remember and put inside your mind. Layer by layer. Okay, so BFS, it processes the node in a layer by layer order fashion. Okay, so what exactly are the layers? So imagine that in your program, you trigger your BFS function from node number 0. Okay, so in the main function, so main function जो हमारा C++ में होगा, we will be triggering something like BFS of 0 in our main program. So we know that the initial point to start, okay, so initial point to start our BFS journey would be the node 0. Now we say the initial node is always at level 0. Okay, the initial node is always at level 0. Let me scroll it a bit. So the initial node here, initial node will be always at 0th level. Okay, so which is the node at 0th level? So we have 0 to be at 0th level. Okay, then next coming to the first level node. So this is at the 0th level node. So next, what do we mean by first level nodes? Okay, so first level nodes are the neighbors of the initial node. Neighbors of initial node. okay, so neighbors of the initial node are known to be the first level nodes. So here we have this to be at the 0th level, okay, and this is also the initial node, okay, denoted by IN. Let me put a star here as well. So this IN indicates the initial node. So now which are the neighbors of the initial node? Okay, so neighbors are the nodes that are present in the adjacency list of that particular node. Okay, so which are connected via a single edge. So here the neighbors of the immediate neighbors of 0 would be 1, 2 and 3. Okay, so here it will be 1, 2 and 3, 1, 2 and 3, which are the neighbors of 0. Okay, and these are said to be in the first level nodes. First. Let me write it down here. Now, which are the neighbors of the neighbors? Okay, so neighbors of the neighbor. Okay, so 0 का neighbor कौन है? 2. इनके neighbor कौन है? Okay, so यहाँ पे 4 and 5 है. 0 का neighbor है 3. इनका neighbor कौन है? So 3 doesn't have any neighbor. Here who is the neighbor of 0? So here we have the neighbor of 0 to be 1. And इनके neighbor कौन है? इसका neighbor only 6 है. ठीक है, so these are all the second level node. So this is the second level node. This also is a second level node. Now neighbors of the neighbors of the neighbor. So as a thumb rule, you can say that how many times are you saying neighbor, okay, from your mouth? How many times are you saying the word neighbor from your mouth in order to reach that particular node? Okay, so let's do it for 6. Okay, so neighbors of the neighbor. Okay, so you told neighbors of the neighbor. Okay, you told neighbor 2 times. So this is at the second level. Now let's do it for node number 7. So neighbors of the neighbors of the neighbors. So you told it 3 times. Okay, so 3 times you told. So this is supposed to be the third level. So in a nutshell, level is how many times you are telling neighbor from your mouth in order to reach that particular node, or how many jumps you have to make to reach that particular node. So here the second level. So here the second level node would be what all? So here we have 6, 5 and 4. 6, 5 and 4 are the second level node, and then third level nodes here would be 7. So these are the levels that are present over here. So we have 0 in the 0th level. Okay, so this is also the initial node, and then we have 1, 2 and 3 to be present in the first level. Then we have 6, 5 and 4 to be present in the second level. That is 6, 5 and 4 present in second level. Then on the third level we have just one element. Okay, so this would be the third level element. Okay, and this is the node number 7. Okay, and BFS makes sure that we are processing all the nodes in a given level first before moving on to the next level. That means we would be processing the node 0 first before we even move to 1, 2, 3. Okay, we would be processing all the nodes in the first level, that is 1, 2, 3, before we move on to 6, 5, 4. We cannot process the node number 5 before we have finished processing 1, 2 and 3. Okay, so this is known as the level by level order processing. Okay, so if you just do it radially also, so you would see that this is the 0th level, then this is the first level that we need to process. Then on the second level it would be something like this that we are processing, and then on the third level that we are processing. So it is a radial type of layer by layer processing that we are doing over here. Okay, so BFS is just that. You just need to process all the nodes in a given level first before moving on to the next level. And the order in which you process the nodes in a given level, it doesn't matter. So you can have, for example, in the second level, you can have the processing order to be 6, 5, 4 or 5, 4, 6 or 4, 5, 6. Okay, so it doesn't matter. You just need to make sure that you are processing all the nodes in a given level first before moving on to the next level. Okay, so that is all about BFS. That's the only thing that we need to remember. Now let's discuss how we can use the queue in order to process it in a level by level fashion. So let me make a little bit of space here. So say for example, we are invoking the BFS of 0 in our main program. Okay, so the initial node basically is 0, the node number 0 here. Okay, so now what we do is we push the element. So imagine that we are maintaining a queue. We push the element 0 to the queue. Okay, so 0 will come and sit something like this. Okay, so this is our queue that we are maintaining for processing, and we are also maintaining the visited array in order to just maintain like which are the nodes that are already visited. Okay, so we have 1 0 1 2 3 4 5 6, and then you have for 7. Okay, so this is the visited array, and it will be containing true or false, indicating whether that particular node was visited or not. Okay, so that is the only thing that it maintains. So now what we do, we started our journey from BFS of 0. So 0 is the first element that needs to be processed. So we just put it inside the queue, and 0 comes and sits something like this. Okay, so next what we do is we mark this 0th vertex to be true. Okay, so whether, okay, so since we have already visited this 0 node, right? So we mark it to be true. Initially all of them are false. Okay, initially all the elements, all the values in the visited array is false, that indicating that none of the nodes are visited. Now since we started our journey on the node 0, we are marking node 0 to be visited. Okay, so next what we do is we will see which are the neighbors of 0. Okay, so we want to process in level by level fashion, right? So what we'll do is we'll find which are the neighbors of 0. And where do we get that from? We get that from graph of 0. So adjacency list, it will be storing all the neighbors of 0, and we can simply query graph of 0, that is graph of the node will give you the neighbors of that particular node. So we'll simply say graph of 0, it will be having 1, 2 and 3 in it. Okay, so it will be having 1, 2 and 3 in it. So what we do, we will push all these elements which are not visited. Okay, so 1, 2 and 3. So here they are not visited, right? So if they are not visited, we'll simply push them into the queue and mark them to be visited. Okay, so what we do, so from 0, we'll see that, we'll ask 1, are you visited or not? Are you already visited or not? It will say that I'm unvisited. Okay, so what I'll do is I'll just put 1 into the queue. Okay, and mark it as visited here inside the visited array. Okay, then next we come to maybe 3, and we'll ask 3, okay 3, are you visited or not? So 3 will say I'm not visited, so you can put me into the queue. So here 3 goes and sits after 1. Okay, and we mark 3 to be visited here. Next we have the node number 2, so we'll ask 2, okay 2, are you visited or not? So 2 will say I'm not visited, you can put me into the queue. So 2 comes and sits after 3 over here, and we can mark it to be true here. Okay, are there any other nodes that are neighbors of 0 that are like not asked for? So there are none. Okay, so here you can see that all the first level element are sitting in the queue waiting to be processed after 0. Okay, so 0 was our 0th wala level, 0th level element. After that we simply queried all the neighbors of 0 which were unvisited, and if they were unvisited, we marked them visited and we put them into the queue to be processed. Okay, so what we do, once we have like queried all the neighbors of 0, we can simply say that we can simply remove 0 from the queue. Okay, so 0 will be removed from the queue, and now the front element is the number 1. Okay, so the same thing we'll do with 1 also. So where is 1? So we have 1 over here. So 1 will ask the same question. Okay, so we'll ask the same question. Okay, 1, so who are your neighbors? So 1 will say I have neighbor 0 and 6. Okay, so we will see which are the unvisited neighbor of 1, unvisited neighbors of 1. So we'll ask 0, okay, are you visited or not? So 0 will say I'm already visited. And where can you get that information? You can get that information from visited array that we are maintaining. So visited of 0 will query, so it will return us true. That means we do not need to process, it's already processed. Okay, so we'll simply ignore this one, and again we'll ask which is the other neighbor that you have. So 1 will say I have the neighbor 6. So we'll ask the node number 6, okay, are you visited or not? So 6 will say that I'm unvisited till now. So what you can do is you can put me into the queue. Okay, so 6 will be put after the last element in the queue, and we'll mark 6 to be visited here. So this will have true now. Okay, so next 6 is already done, and there are no more neighbors of 1 that needs to be asked. So 1 can be removed from the queue as well. Okay, so we remove 1, and the next element is 3 inside the queue. Okay, so 3 is available. Now we'll do the same operation for 3. For 3, where is 3? So 3 is over here. So we'll ask 3, which are your neighbors? So 3 will say I do not have any neighbors. You can just do the processing whatever you want with me, and you can just remove me from the queue. So 3 will get removed from the queue. Okay, since it doesn't have any neighbors, we don't have to push any element into the queue. All right, so next, which is the element that needs to be processed? It is always, so just remember, it is always the front element from the queue that is that will be processed. Okay, so for front element in the queue, it is always the front element in the queue that needs to be processed. So we have the next element to be 2. So we'll do the same operation with 2. So we'll ask 2, which are your neighbors? So 2 will say, I have neighbor 0, 4 and 5. And it'll ask 0. Okay, 0, are you already visited or not? So 0 will say, yes, I'm already visited. So you can just ignore me. Then you have the node 5. So node 5, are you visited or not? So node 5 here will go and query. So node 5 tells that I'm not visited yet. Okay, so it will simply put the node number 5 into the queue. So node number 5 goes and sits over here. Okay, and then after that, after 5 is done, so we'll ask which are the other neighbors of 2. So it will say 4 is there. So I just ask 4. So 4 will say I'm not visited yet. So since here we do not have the true entry, so 4 will say I'm not visited yet. You can just put me into the queue and mark me as visited. Okay, so 4 will come and sit over here, and we'll mark this also to be visited. Okay, 5 we need to mark it as visited since we have pushed it into the queue. Okay, so now this would be the state, and as you can see here that these are all the second level element. Okay, so these are all the second level element. Now what we do is we'll remove 2 from the queue since all of its neighbors are done, right? So we'll remove 2 from the queue. Okay, so this is the processing order that we are following. So we process the 0th level first, then we process the first level after that. So you can see that all these nodes are processed after that. And then we have 6 next in the queue. So where is 6? So 6 is over here. So we'll ask the same question, which are your neighbors? So it will say 1 and 7. 1 is already visited. You can get it from the visited array. Okay, so we just ignore 1, and then we'll ask which are the other neighbors. So it will say 7. Is 7 visited? So here we have empty, right? So 7 is not visited. So 7 needs to be pushed into the queue. So we'll just push 7 into the queue and mark this to be visited. Okay, 7 will be marked as visited, and there are no more neighbors to be processed, so it will just remove 6 from the queue. Next, coming to 5, where is 5? So 5 is over here. Which are the neighbors of 5? So it is 2, and there is nothing more over here. So 2 is already visited, so we can simply remove 5. Processing part is something that you can write code for anything. You can either print a square, print the cube, or do any primality check or anything what you want to do that with that particular node, you can do that. But then the only thing that we are concerned over here is what is the order in which they are getting processed. Okay, so 5 is done. Okay, so 5 is also visited. So this is visited. So everything is visited basically. So here you can see that everything is visited. But then order is this one. So after 5, okay, which is the next in the queue? So we have 4. So 4 is over here, which is the neighbors of 4. 2 is there. 2 is already visited, and there is nothing else over here. So this also you can just process and remove from the queue. We come to 7. So 7 is over here, which is the neighbor of 7. So neighbor of 7 is 6. You just query 6. Is it already visited? It says true, and there are nothing more. So you can just eliminate over here. Okay, and now the queue, since you have removed all the entries from the queue, it will look something like this. And here is the terminating condition of the BFS algorithm. Okay, when the queue becomes empty, there are no more nodes to be processed, and this is the place you know that your BFS traversal is complete. Okay, so this is the queue.empty check. Okay, so empty function I had explained you, right? We just need to do this while not queue.empty. Okay, जब तक queue खाली नहीं हो जाता, we need to carry out this traversal. Basically, take out the front element from the queue and just do the same way that we are doing. Just query the neighbors of that. Okay, so just query the neighbors of that particular node. Ask which of them are unvisited and put them into the queue and mark them visited. So this is the entire flow that we are following for BFS. Okay, so let's write the algorithm for this particular approach over here. Okay, सबसे पहले हमको क्या करना है? सबसे पहले हमको अपने variables define करना है. So we need to define a variable called, say for example, we have queue, and then we are also maintaining a visited वाला array. Okay, so this is a visited array and this is of type boolean. ठीक है, boolean मतलब true and false आपको बताएगा कि whether that node is visited or not. So next what we need to do is we need to push the first element, the initial node, into the queue. Push initial node into the queue. Okay, so this push operation we need to do. Just mark visited of initial node. Okay, so initial node mark visited of initial node to be equal to true. Okay, so we need to mark it to be true. Okay, and then what we need to do is we need to execute while not q.empty. Okay, so we need, so this while not q.empty simply over here, it simply means that till the time there are still elements present into the queue, okay, till the time the queue is not empty, we need to take the first element from the queue. So it is, let me write the body of it. So it will be like, we need to take the front element from the queue, and how do we get it? We get it from queue.front. Okay, so we need to take the front element from the queue, remove the front element from the queue. Okay, so we have already got the front element, right, in this. So we can simply remove the front element of the queue so that the queue size reduces by 1. Okay, and now whatever processing that you want to do, you can do it over here. So processing, maybe you want to print the square, cube, etc, etc. So you can do it over here. And then after this, what I want to do is the thing that we were doing, right, we were asking all the neighbors which are unvisited. Okay, which are unvisited, we were putting that into the queue and we were marking it to visited. So this we need to do over here. So what we'll do is for, let me write it in this. Okay, for neighbor in, for neighbor in graph of node. Okay, so for the neighbor in graph of node, like basically just getting all the, like for all the nodes that are in the adjacency list of that particular node. Okay, so which is this particular, so what is this node? So this is the front element that we have taken out from the queue. Okay, so let me write it front element itself. Okay, for neighbor in graph of front element, for neighbor in graph of front element, we check if that neighbor is not visited. We check if that neighbor is not visited. Okay, so for visited, जो भी अगर visited हो गया उसको तो हम ignore कर सकते हैं. If the neighbor is not visited, what we do is we push that into the queue सबसे पहले. So push neighbor. ठीक है, सबसे पहले हम क्या करेंगे, उसको हम queue के अंदर push कर रहे थे, right? यहाँ पे take for example over here, we were finding out which are the neighbors of that particular node. So यहाँ पे हमको पता चल जाता था कि कौन कौन सा node है जो already visited है. ठीक है, so यहाँ पे visited है उसको तो हम ignore कर देते थे, but then whichever was not visited, we were first pushing that element into the queue and then we were marking it to be visited over here. Okay, so the same thing, we need to put that into the algorithm. So if the neighbor is not visited, we first push the element into the queue, push the neighbor, that particular node into the queue, and mark visited of neighbor is equal to true. Okay, so this is the only thing that we need to do, and this is our BFS algorithm. Okay, this is it. Okay, so this is it. So this is our BFS algorithm. So let me go through it once again. So what we do is we declare the queue first and then we declare the visited boolean array. So this is the queue that we were talking about, and this is a visited array. So we are declaring that first, and then after that we push the initial node into the queue. So initial node को हम push करेंगे. So that here we had the initial node to be 0. So we were pushing the node into the queue first. Okay, ताकि हमारा ये while loop execute होना start हो जाए. Okay, and we were also like marking this visited of initial node to be true. So what we did, so यहाँ पे visited of 0 we did to be true, right? So initial में, so that thing marking the 0th vertex to be visited is over in this particular line, and then we are triggering the while not queue.empty. So we were simply saying that, right? So we are saying that, right, जब तक queue खाली नहीं हो जाता, we need to keep on taking the front element from the queue, processing it, and then querying all its neighbors, whether they are unvisited or not. That thing is happening in this particular while loop. So front element is equal to queue.front. So we take out the front element. So next is queue.pop. So queue.pop simply make sure that we are removing the front element from the queue. Okay, so so that it doesn't go in an infinite loop. So if we do not remove an element itself, this while loop will never end, right? So we are accessing, like we are storing the front element, via q.front, and we are removing it then and there. Okay, taki later point of time we don't forget to remove. You can remove it even later on, it doesn't matter. But then q.pop is simply to remove the element from the queue. And then if you want to do any processing with that front element, you can do it over here in the middle part. Okay, and then the main thing that we want to do is next is for all the neighbors in graph of front element, that is for all the neighbors in adjacency list of that particular node, that is 2 ka kya hoga, 2 ka hoga 4, 5 and 0. Graph of 2 will return 4, 5 and 0, which are the neighbors of 2. Graph of 1 will return 0, 6, which are the neighbors of 1. Graph of 3 will return 0, which is the neighbor of 3. Okay, so for all those neighbors in graph of, so basically for all the neighbors of that particular node, we are checking if the neighbor is not visited. Okay, so we are checking if the neighbor is not visited. So if the neighbor was already visited, we were simply ignoring. Okay, so we don't care when it's already visited. We only care when the node is not visited, so that we can put that node into the queue and mark it to be visited. Okay, same thing we are doing over here. If the neighbor is not visited, मतलब अगर neighbor को हमने visit नहीं किया है, we push the element into the queue first and then we mark it to be visited. So this is the BFS algorithm. Okay, all right, so let's write down the code for this in C++. Okay, so I have opened the VS Code editor over here. So the very first thing that we need to do is we need to declare the graph first. Okay, so this particular graph that we have over here. So let's define the graph first. So I will declare the graph to be something like vector int graph, and here the total, what is the total number of nodes here? So we have total of 8 nodes here. Okay, so let me declare a variable called constant int total nodes is equal to 8. Okay, total nodes is equal to 8, and we'll use this particular variable into our program. So this declares the adjacency list. Okay, so now let's make a function that can add edge to the graph. Okay, so void add edge, and the very first parameter would be the graph itself, vector int graph, int source, and int destination, and here we need to add the undirected edges. So we'll have statements like source dot pushback destination and graph of destination dot pushback source. Okay, so this two statements need to be present for an undirected edge. If it was a directed edge, only a single statement would be present, indicating an arrow from the source to a destination node. Okay, so we have the add edge function over here. Now what we'll do is let's add the different edges that we have in the graph. So the very first is we have an edge between 0, 1, 0, 2 and 0, 3. Okay, so I'll call this one. So add edge graph 0, 1. Okay, I'll just copy this line, and we have 0, 1, 0, 2 and 0, 3. Okay, so 0, 1, 0, 2, let me mark as well so that I can keep a track. So this one is done, this one is done, and this one is done. So 0, 1, 0, 2 and 0, 3. Next we have an edge between 2, 4 and 2, 5. Okay, so we have an edge between 2, 4 and 2, 5. Okay, 2, 4 and 2, 5. So these two are also done. Next we have an edge between 1, 6 and 6, 7. Okay, so we have an edge between 1, 6 and 1, 6 and 6, 7. Okay, 6, 7. Okay, so now we have like 1, 2, 3, 4, 5, 6 and 7. Okay, so total of 7 edges has been established. Okay, so we have like completed making our graph. Okay, so next what we need to do is we need to make a call to BFS of 0. Alright, so here we'll do something like BFS, and किस पे हमको BFS रन करना है? On the graph, and कौन से node से रन करना है? 0 से रन करना है. Okay, so let me make a variable called initial node is equal to 0, and let me pass this initial node to this function here. Okay, so now this BFS function is something that we need to implement. Alright, so I will declare void BFS. Okay, void BFS, obviously taking the first element to be the graph itself, and then the initial node where we are starting. Okay, so initial node is the point where we are starting. So in this particular thing, we have the initial node to be 0. So when we are running the program, right, we'll just change the initial node value to 2, then we'll change it to 6 and then see the output. Okay, so as of now, we'll just consider it to be 0. So what I've done is I just take the graph, I take the initial node, and let's open the algorithm part of it, and let's convert that algorithm into the C++ code. Okay, so we need to first declare the queue. Okay, so this is something that we need to declare first, queue and the visited array. So I will declare the queue of int q and vector of bool, and this is called visited, and इसका size क्या होगा, total node का size होगा, and सारे elements initially would be false. Okay, so q is equal to q. So this is how you can declare a queue. Okay, and the type of the queue is set to be int because that is the type of the data our graph stores. Okay, so queue of int I have declared, and visited array I have declared. Okay, so this is the first part that we have done. So we have declared the queue, and then we have declared the visited array. Next, what we need to do is we need to push the initial node to the queue. So what I'll do is I will do q.push initial node. Okay, so q.push initial node. So let's push the initial node to the queue. Okay, and the next step क्या है हमारा, we need to mark the initial node that we have pushed to be visited of initial node is equal to true. Okay, so what we'll do is visited of initial node is equal to true. Okay, so I'll say mark the initial node to be true, initial node to be 2, that is mark the initial node to be visited, I would say, to be visited. And then this is also done, then we need to trigger the while loop. We'll say while not q.empty. Okay, so while not q.empty, मतलब जब तक queue खाली नहीं हो जाता, what we need to do is we need to take out the front element from the queue. Okay, so this is the statement that we are writing now. We need to take the front element from the queue. So I'll say int front element is equal to q.front. ठीक है, so take out the front element from the queue. Okay, and let's remove it as well. So let's remove the element from the queue, its queue also. Okay, so that it doesn't go into infinite loop. And since we also have stored it into our front element variable, right, we do not need it to be present in the queue. Okay, so front element हमारा basically जो हमको pop करना है, so we have already stored that into the front element, so it doesn't make sense to have that element into the queue, so we can remove it from the queue. So we'll do q.pop. Okay, so q.pop will remove that element from the queue, that is the front element from the queue. Okay, now what we need to do is if you want to do any processing, you can do that. So let's do the processing. Basically let's print the square of the number. So we'll say the square, the number is I'll say front element into front element. Okay, so this is the processing part. You can do whatever processing that you want, processing part. Okay, I have just taken a simple example of finding a square. Okay, and now what we need to do is we need to query all the neighbors of that front element. Okay, so I'll say for int neighbor in graph of front element. Okay, for int neighbor of graph of front element. So this is a for each kind of loop that I'm using. Okay, so for int neighbor in graph of front element, what we need to do is we need to check if the neighbor is not visited. Okay, so if the neighbor is not visited, if not visited, it not visited of neighbor. Okay, if the neighbor is not visited, so here I'll say if the neighbor is not visited, we push that element in the queue first, right? So यहाँ पे हमारा है if the neighbor is not visited, we push that element, we push that neighbor into the queue, that is push the neighbor in the queue. So we'll have queue dot push neighbor, okay, and then we need to mark neighbor to be true, okay, to be visited of neighbor to be equal to true. So that so here we are doing the same. So we'll say visited of neighbor is equal to true. Okay, so that's pretty much it. So this is our BFS function, and let's try to run this particular BFS function, and I'll say g++ bfs.cpp. Okay, and let me run it as well, ./a.exe. So here we can see that the square of the different numbers are printed. So let's print the node which is getting processed, the name of the node that is getting processed, instead of the square of the number, because the order is something that we are more concerned with. So I'll say processing node, I'll say front element, so that is more clear to us, and we can track that by comparing it from our drawn graph as well. Okay, so let's say g++ bfs.cpp and /a.exe. So here we can see that the very first node that is getting processed is 0. Okay, so since we triggered our BFS function from 0, here we have 0. Let me get the output over here. Let me zoom out a bit, and right, so here we can see that first we are getting the statement like processing node 0. So this 0 is something that is processed first. Then we have processing node 1, 2 and 3. So 1, 2 and 3, so these are all the first level node that are getting processed, and after that we have node 6, 4 and 5 that is getting processed. So we have 6, 4 and 5 that is getting processed after that, and then at the last we have the node 7 that is getting processed, which is at the third level. So that is how we maintain the level by level processing. Okay, now let's imagine that we are triggering our BFS from this particular node. So BFS of 2 we are triggering. So यहाँ पे what should be the order? So first 2 should be processed, then the node 4, 5 and 0, it can be in any order. 4, 5 and 0, it can be in any order. Then after the first level, we can have the second level nodes, that is 3 and 1. Okay, after that you need to have 3 and 1, then you can have 6, then you can have 7. Okay, so this should be the order in which they're getting processed. Let's try that out. Okay, so what I'll do is I'll go to the program and I will just change the initial node to be 2. Okay, so we wanted to trigger it from here, right? So I'll just change the initial node to be true, and let me compile the program again, and I will say g++ bfs.cpp and /a.exe. Right, so let's track the output. So we have 2 that is getting processed first, that is the initial node. Then we have the first level node to be 4, 5 and 0. Then second level of node to be 1 and 3. Okay, so this 1 and 3 after that. So 1 and 3 is at the second level, 0, 4 and 5 is the first level, and then you have 6 to be in the third level, 7 to be in the fourth level. Okay, so we are getting the correct output. So that is how BFS processes the data. So in the next video, we'll try to use BFS for getting our first level connection, second level connection, third level connection in LinkedIn. Okay, so we'll just take a dummy data and we'll try to implement a BFS function so that we can kind of mimic what LinkedIn does. Okay, so see you in the next video.